Hello, in this video, I will do example 2 of a demand function word problem. So example 2 states, a company's cost of producing X item, C of X, equals 2600 plus 2X plus 0.001X squared. Find the cost, the average cost, and the marginal cost of producing 100 items. Then find what the production level will be. Will the average cost be lowest? Find the minimum average cost. So there's a lot going on. So we need to find the cost, the average cost, and the marginal cost of 100 items. So that's part A. And then it says, then find the production level that the average cost will be the lowest, meaning we need to find a minimum, right? And how do we find a minimum? By taking first derivative and setting it to 0. And then, yeah, so we find the minimum. So that is minimum. So let's do the first part. So what is our cost function? Our C of X is 2600. Okay. So find the cost of $100. So this one, that's not too hard, right? You just plug in 100. 100, your X is your units. So plug in 100 into the cost function. Okay, so when I go ahead and put that in the calculator, I get exactly 110. So for X amount of, for 100 items, it would cost the company $2,810. Okay, the next part says find the average cost. So how do you find the average cost? You basically take the cost function and divide everything by X, right? So let's do that first. So let's find the cost function. So C of X equals, that's just the cost function. And divide that whole thing by X. That's it. And you could simplify this if you want. So if you divide everything by X, that's what I'm going to do. So every term by X. So on the numerator is how many terms? 1, 2, 3. There's 3 terms. So divide everything by X. So it'd be 2600 over X plus what's 2X over X? Just 2. Plus what's 0.001X squared over X? That's 0.001X. Okay, so this is your average cost function. Now we got to plug in 100 units in our average cost function. Okay, and when you put it all together, you get $28.10. Oh, let me box this one as well. Okay, so the third thing for part, they're also asking the marginal cost for producing 100 items. So how do you find the marginal cost? Basically, it's just the cost function of its first derivative, right? So you can also express it as dc over dx. You can also express it as c prime of x. It's the same thing. So where is your c function is right here. No, actually your c, where's your just regular, it's this one. So your c of x is 2600 2x plus 0.001x. Just take the derivative. So this one, the first, the derivative of 2600 is 0. The derivative of 2x is 2. The derivative of 0.01x squared is using power rule. So 2 times 0.01 is 0.002. Okay, so let me write that out. So C prime of x is 2 plus 0.002x. Okay, then we got to plug in 100. And when I do that, I get exactly $2.20. Okay, so that was like the first part of the problem. They're asking find the cost, average cost, and marginal cost of 100 items. And then the second part says, then find the production level, then find what production level will the average cost be the lowest. So what is our average cost function? It's right here, or this one right here. Right, so let me write that down. So the average cost function is 2,600 over x plus 2 plus 0.001x. Then, so how do you find the minimum? You take the derivative, set it to 0. So let's take the derivatives. Well, actually, let me rewrite this part right here. That could also be expressed as 2,600 x to the -1. You could have used quotient rule. I didn't want to use the quotient rule because it just seemed like a lot of work. And now let's take the derivative of each term. So the first term you apply the power rule. So this would be -1 times 2,600 is -2,600 x to the -2. The derivative of 2 is 0. The derivative of 0.001x is 0.001. Okay, so go ahead and set that to 0. And go ahead and solve for x, or go and try to attempt to solve for x. This -2,600x to the -2, I can rewrite that as -2,600 over x squared. Okay, and then just move this 0.001 to the left by subtracting. Okay, so this is -0.001. And then this is -2,600 for x squared. Okay, go ahead and cross multiply. So x squared times that is -0.001x squared. 1 times -2,600 is -2,600. Go in and solve for x. So I'm going to divide both sides by -0.001 divided by -0.001. So that is x squared equals to 26. And then how many zeros? It would be 26. 5 zeros. And then solve for x, so you're going to take the square root of both sides. You know, it wouldn't make sense to use, and so remember when you take the square, you get a plus or minus. I think you're going to exclude the minus because you don't want to have a negative profit. So let's use the positive. So what's the square root of 26? It's going to be 1612.45, but let's use whole numbers because it wouldn't make sense to use half a quantity, right? Yeah, you don't want to produce a negative amount of quantity. So this would be 1612. Okay. So what was the question again? It said, then find the production level, then find what the production level will the average cost be the lowest, find the minimum average cost. So I think we did find the production level, which is x equals 1612. But we gotta prove that it's actually gonna produce a minimum. So how do we prove that? By doing our test point method, right? So go ahead and put 1612 right in the middle. Here's part one, here's part two. And then what we're going to do is put it in your average cost derivative. And let's pick a number less than 1612. I cannot use 0, so maybe I'll use 1. And when you plug in 1, you get an output of negative 250. Now, I don't care about the number itself, I just care about the sign. So it's negative and a minus. And then let's test region 2. I need a number slightly larger than 1612. So maybe I could do 1613. When you put that in, you get negative 2600. You get a positive value. I forget the number, but I know it's positive. So go ahead and put a plus. So according to your line chart, your sign chart, if you have a minus and a plus, do you have a local min? Okay, so this proves that the quantity x equals 1612 will produce a minimum. But the second part actually says, find the minimum average cost. So I believe that is going to be a y value. And how do you do that is you plug in the x value, 1612, into your average cost, right? So plug in average cost and then plug in the x value, 1612. So that's going to be 2600 over 1612. It's 2 plus 0.001, 1612. Put it all together, you get $5.22 per unit. Okay, so yeah, so that was the answer for the second part. So at x equals 1612, we'll give you the average cost to be the lowest, and then the actual minimum average cost is $5.22 per unit. Okay, that wraps it up for that example 2.